Hello, this video is going to give you some more practice at simplifying complex fractions. So the worksheet that hopefully I gave this to you in class today, I'm going to have you use the technique that you were taught in the last video to simplify this complex fraction. If you remember, the first step is to find the LCD among every single term that you see. So you have 3 terms, and the LCD amongst all of them is equal to y plus 3. So what we're going to do is we're going to multiply every single term by y plus 3. I'm going to shortcut a little bit. I'm going to put a great big y plus 3 up here at the top, and we're going to multiply that term and the 1 and that term by y plus 3, and that's going to clear the denominators. So now what we have, let's just take a look at this first numerator. If we cancel out this y plus 3 with this y plus 3, all you're going to be left with is a y. That's the top. Down here on the bottom, if we multiply y plus 3 times 1, we're going to get y plus 3. And here, if we multiply y plus 3 times a negative y over y plus 3, the y plus 3 will cancel, and you're left with negative y. And then the only thing left to do now is to subtract y minus y to simplify that denominator. So our final answer is y over y minus y is 0, and 0 plus 3 is 3. So that would be the final simplified answer for number 1. Number 2, when we look across all the denominators, we only have 2 of them. We have a 2x and a 4x. We try to think to ourselves, what is the smallest, or what's the least monomial that 2x and 4x will go into? Well, this LCD is equal to 4x, not 4x squared, just 4x. So we're going to multiply everything by 4x. I think I will put a 4x by everything this time. 4x here, 4x here, 4x here, and a 4x here. All 4 of those parts get multiplied by 4x. 5 times 4x is 20x. The 4x and the 2x, well, how does that simplify? The x's will cancel out, and 4 over 2 reduces down to 2 over 1. And you're left with plus 5 times 2, which is plus 10. On the bottom, the 4x here will cancel out with that 4x there, and you're left with a 1. Don't forget the 1. And then you subtract from that, x times 4x is 4x squared. Well, there's a couple more things we can do with this because this is factorable and this is factorable, so let's try to simplify. In the numerator, there's a GCF. It's 10, so we pull the 10 out, and you're left with 10 times 2 is 20, x, and then don't forget the plus 1 here, because 10 over 10 is 1. So that one's factored. Down here we have DOTPS, difference of 2 perfect squares. 1 is a perfect square, and so is 4x squared. So that factors into 2 binomials. 1 plus 2x, 1 minus 2x. Don't forget to take the square root of both the 4 and the x squared. And then we can see that 2x plus 1 and 1 plus 2x, even though they're in opposite positions, as long as it's addition, they are exactly the same, because you can kind of think of it like this. 2 plus 1 is the same thing as 1 plus 2, right? So 2x plus 1 is the same thing as 1 plus 2x. So if they're the same thing, they cancel. And what you're left with in the top is a 10. Didn't cross that one out yet. And in the bottom, you're left with a 1 minus 2x. And don't divide out the 10 and the 2 because 2x is a term. So that would be the end of that problem. Over here in number 3, well, we have a few denominators. We have an x and an x squared and an x. And we try to think of the lowest, the least common term that all 3 x and x squared will go into. Well, the lowest one that all 3 will go into is x squared. So we'll write that off to the side. So let's write an x squared next to all 3 of those terms. Here's an x squared next to the 1. Here's an x squared next to the 6. and here's an x squared next to the 9. And here's an x squared next to the 3 over x, and here's an x squared. Don't forget to write it also next to that 1, 4 places. Next thing we're going to do is multiply. X squared times 1 is equal to x squared. Over here we have a minus because of that minus. X squared on the top and an x on the bottom. The x will cancel with one of those two x's, and you're going to be left with x times 6, which is 6x. In this last term we have a plus sign, and the x squareds cancel, and you're left with 9. In the denominator, x squared times 3 over x, well, if you put a 1 underneath that, you'll know that this in the bottom will cancel with one of these two x's in the top, and you're just left with an x. Oh, times 3. And on the bottom, negative 1 times x squared is negative 1x squared, or just negative x squared. So that's your first step, is to clear the denominators. The next thing we can do is we can notice that this is factorable. There are factors of 9 that add up to negative 6. Well, what are they? What times what is 9? Well, 3 times 3, and also negative 3 times negative 3 is positive 9, and they also add up to negative 6. I see a GCF here. I see an x in both terms, so let's pull out the x out in front of parentheses, and you're left with 3 minus x. So there's your factored version. Now what we have is an x minus 3 on the top and a 3 minus x on the bottom. Remember, when it's subtracted and they're in the opposite positions during a subtraction, they are, you do cancel them, but you cancel them out to a negative 1 because in the opposite position they're subtracted. So you can write the answer as negative 1 times x minus 3. You can write it like this, negative 1 times x minus 3, all over the x didn't cancel. You can write that and leave it like that. That is fine. Or if you don't want to write the 1 there, you can just leave it as negative parentheses x minus 3. Or if you're really ambitious and you want to do some more work, you can distribute this negative 1 and you can call it negative x plus 3 all over x. But don't cancel those x's, because this x up here is a term because it's next to that plus sign. So either one of these is correct. It doesn't really matter how you write it. The next one. Now we have the same situation as the one above. We have an x and an x squared, an x and an x squared. So whenever that happens, you're going to take the highest exponent, which is x squared, and make that your LCD. So this LCD is x squared again, just like the last one. You're going to multiply everything by x squared. So put an x squared next to all 6 terms. You got 3 on the top, you got 3 on the bottom. Put them next to every single term. That'll clear the denominators. X squared times 1 is x squared. This x in the denominator cancels out with one of those x's up in the numerator, and you're left with a negative 5x. The x squared in this denominator cancels out with that x squared in the numerator, and you're left with a plus 6. On the bottom, x squared times 1 is x squared. X on the bottom cancels out with one of those two x's on the top, and you're left with minus 6x. And at the end, x squareds cancel, you're left with plus 8. Don't cancel out the x squares, they're terms, but you can see that this is factorable. There are factors of 6 that add up to negative 5. Well, what are they? They are negative 3 times negative 2. Don't think about 6 and 1, because they both have to have the same signs. Negative 3 times negative 2 is positive 6. Negative 3 plus negative 2 is negative 5. So that's the only way you can factor that one. The factors of positive 8 that add up to negative 6 are 4 and 2, a negative 4, and a negative 2. And now the x minus 2's will cancel, and all you're left with is x minus 3 on the top x minus 4 on the bottom. Don't cancel those x's, they are terms. And then the last problem, this one is a little tricky because what we have is a plus b, which is not the same as a minus b because one is a plus and one is a minus. They're not the same at all. In the denominator, you have a difference of two perfect squares. So what I'm going to do is I'm going to factor this denominator down here, DOTPS, a plus b times a minus b is that denominator. So now I'm going to look across all those denominators and I'm going to start building that LCD. Well, what is the LCD? We have to pick up everything. We have to pick up the a plus b from here. We have to pick up the a minus b from here. They're different. We've already got the a plus b, so we don't write it again, and we've already got the a minus b. We don't write that again. So there is our LCD, a plus b times a minus b. Let's write that next to every single term. I think I'll write it like this. A plus b times a minus b here. A plus b times a minus b here. A plus b times a minus b here. 3 places. What can happen? The a plus b's will cancel here and here, and you're left with 2 times a minus b, which is just 2a minus 2b. Over here in this term, the a minus b's cancel out. And you're left with, look at this, this is a negative 2 times a plus b. So negative 2 times a is negative 2a. Negative 2 times b is negative 2b. And then on the bottom, the a plus b's cancel, the a minus b's cancel, and you're just left with a 4 because we did not cancel that 4 out. So now let's clean this up. What can we do? 2a minus 2a is 0. Negative 2b minus 2b, well, negative 2 minus 2 is negative 4. So negative 2b minus 2b is negative 4b. And now we're left with a negative 4 times b all over positive 4. These are not terms. This is a factor. Factors can cancel. If this were a plus sign or a minus, you could not cancel, but this is multiplication. Multiplication means that's a factor, so we can cancel this 4 out with this 4, and we're left with a negative 1 times b, which is just negative b. If you want to put the 1 underneath, you can, but you don't have to. Just leave it as negative b. That looks like a 6, kind of. Make sure it looks like a b. And that's the end of that problem. And I'll see you tomorrow. Have a good night.